All right, in this one, we're going to look at some Year 12 material, just in sort of looking ahead, really, because it makes sense to cover this between alcohols and carboxylic acids, and you'll see why in a moment. So we're going to look at aldehydes and ketones, which are very similar types of molecules. There's only a slight difference between them. Aldehydes we'll start with. This is taken from the Wikipedia page of uses, so used in tanning, preserving, embalming, and also in germicides, fungicides, and insecticides. I remember my chemistry teacher saying basically that this was nasty stuff, basically is what he said. So it's a pretty rough chemical, I think, and it's not something you want to mess around with. Now, we make it from oxidizing a primary alcohol. So remember, primary alcohols are where the alcohol group, the functional group, is attached to the end of the carbon chain. So the carbon that it's attached to has 2 hydrogens on it. And by oxidizing this with an oxidizing agent, don't worry about what that is, but just a chemical that we can use to oxidize it, that we've shown it as O, it will oxidize it, and by doing so, it takes off the hydrogen from there, and it takes off the hydrogen from there, forming water, and it leaves a carbon double bond O, which we call a carbonyl group. That's called a carbonyl group. And an H, okay? So that set of 3 there on the end of a molecule of a chain shows that it's an aldehyde. Now the naming of this is pretty straightforward. So the structure is always like this. So you've got a chain followed by a C double bond O, and the homologous series. So the series of aldehydes with their names is like this. So decanal, nonanal, octanal, heptanal, etc. These are the structural formulas. So these would all be carbons on each corner here, just so you know. And we don't need numbers because the aldehyde is always on the end. So we don't need numbers between the deck. So that's how aldehydes work. Next, we're going to move to ketones. Ketones are very similar, but used for very different things. So they're used for making plastics, synthetic fibers, but also as a solvent. You've probably heard of acetone. Acetone is used for nail polish remover because it's such a powerful solvent for organics. Its actual name, IUPAC name, is propanone. It's also used for medicinal purposes. So this is how you make it. You oxidize, again, an alcohol, but this time it is a secondary alcohol. By secondary, we mean that the functional group of the alcohol is attached to a carbon which only has 1 hydrogen on it, and the rest is carbons. Okay, so go back to the alcohol chapter if you want to revise that. So we oxidize it, and by oxidizing it, we take the hydrogens from there and there, forming a double bond O again, just like the aldehyde, and water. But this time, instead of there being an H down here, we have an alkyl group, so just another carbon chain. So the double bond O is sort of halfway along the chain now instead. So you can see some examples of that here. So this is propanone, otherwise known as acetone in its unofficial name. That's the IUPAC name, propanone. We don't need to put a number for propanone because there's only one place you can have the carbonyl group if it's in the middle of the chain. So it's either going to be propanone, or if you put it on the end here, it would be propanal. So that's why we don't need a number for that one. For this one, we've got 1, 2, 5 carbons. Now there is so that's pentanone, and we're going to have to put a number in here because it could be on the 2 position or it could be on the 3 position. The 4 position is the equivalent of the 2, so there's no such thing as the 4 position, so it's either a 2 or 3. So we put a 2 in for there, and then the next one down shows, and that would all depend on what type of alcohol you oxidized. So if you oxidized the alcohol where the OH group was there, then you'd make pentan-3-one. If you oxidized an alcohol where the OH group was here, then obviously you'd make pentan-2-one. Next, we're going to look at carboxylic acids, which is the completely oxidized version of a primary alcohol.